Billions of years ago, long before Earth existed, everything that would one day become our planet was spread out as tiny particles inside a giant cosmic cloud called a nebula. This nebula was made of gas, dust, metals, and the remains of ancient stars that had exploded in violent supernovae. For millions of years, this cloud drifted silently through the Milky Way, cold and dark. But something dramatic happened. A massive star nearby exploded, sending shockwaves rippling through the cloud. These shockwaves disturbed the delicate balance of the nebula and caused the gas and dust inside it to clump together and collapse under their own gravity. This collapse was the first step toward creating the solar system, including the Earth. As the nebula collapsed, gravity pulled everything toward the center, making the cloud spin faster and flatten into a large rotating disk known as the protoplanetary disk. The central region grew hotter and denser with each passing moment until it eventually ignited in a burst of nuclear fusion, becoming the sun surrounding the young sun. The leftover cloud material, gas, metals, ice, and minerals, continued circling in the spinning disk. The temperature differences across this disk determined which materials could survive. Closer to the sun, only metals and rocky materials could endure the heat, which is why the inner planets, including Earth, became rocky worlds. The earliest stage of Earth's formation began with something extremely small, microscopic dust particles. In the swirling disk, these particles collided gently and stuck together due to static charges, forming tiny pebbles. Over time, these pebbles collided to become larger stones, then boulders, and eventually huge mountain-sized objects known as planetesimals. These planetesimals were the true building blocks of planets. Their gravity pulled in more material, causing them to grow bigger and more powerful. When two large planetesimals collided, they sometimes shattered, but more often they fused into even larger bodies called protoplanets. One of these protoplanets, located in the right zone around the Sun, continued growing through endless collisions and gradually became the early Earth. The early Earth was nothing like the beautiful blue planet we know today. It was a molten world, glowing hot from constant asteroid impacts and intense internal heat. Massive objects slammed into Earth regularly, releasing enormous energy that kept the entire surface a raging ocean of lava. During this chaotic era, the young Earth was hit by a Mars-sized object that scientists call Theia. This collision was so powerful that a huge portion of Earth's outer layer was blasted into space. The debris that spun around Earth eventually clumped together and formed the Moon. After this event, Earth slowly began to stabilize, but it remained incredibly hot and hostile for millions of years. As Earth continued releasing heat from its interior, volcanic eruptions became extremely common. These volcanoes released gases such as water vapor, carbon dioxide, sulfur dioxide, methane, and ammonia. These gases formed Earth's very first atmosphere, but it was toxic and had no oxygen at all. Slowly, the planet began to cool. The molten surface hardened into solid rock, creating the first crust. As the temperature dropped, water vapor in the atmosphere condensed and fell as rain. This rain lasted for thousands of years, eventually filling the low-lying areas and creating Earth's first oceans. At the same time, icy comets and asteroids from outer space may have also delivered additional water to the planet, further expanding the oceans. Somewhere in the early oceans, simple microscopic life began. These tiny organisms, probably similar to modern bacteria, lived in environments like underwater volcanic vents. They fed on chemicals and slowly evolved over millions of years. Then, something revolutionary happened. A type of bacteria called cyanobacteria developed the ability to perform photosynthesis. This meant they could use sunlight, water, and carbon dioxide to produce food, and release oxygen as a byproduct. For millions of years, oxygen built up in the oceans and was absorbed by minerals. After those minerals were filled, oxygen began to escape into the atmosphere. This process slowly transformed Earth's air from a toxic mixture into an oxygen-rich environment capable of supporting more complex life forms. With the atmosphere changing, Earth underwent dramatic transformations. The rising oxygen levels created the ozone layer, which protected the surface from harmful solar radiation. The cooling climate stabilized, and the oceans grew deeper and clearer. The magnetic field, generated by Earth's molten iron core, shielded the planet from dangerous cosmic particles, making the environment safer. Over time, life evolved from simple single-celled organisms into more complex creatures, algae, plants, fish, animals, and eventually humans. The Earth that once was a ball of molten rock had become a living world overflowing with biodiversity. When scientists say that Earth was born from thin air, they mean that everything we see today, mountains, oceans, air, plants, animals, came from tiny particles drifting in space. The rocks came from dust grains. The oceans came from vapor and ice. The atmosphere came from gas released by volcanoes. Even life began from simple chemical reactions in water. The entire planet was built from material that originally existed as nothing more than dust and gas floating in a huge cosmic cloud. Through gravity, time, collisions, chemistry, and natural processes, this thin, invisible mixture became our home. Thank you for watching.